Hello. While I'm waiting for the possibility of people showing up tonight, I'm going to go through a few questions that were most missed this week. The first one was looking at a relation that we'll learn next week actually is not a function. So these relations where we have an x and a y value related, we want to plug in either the x or the y value and solve for the other one. So in this case, we have the relation where we have x is equal to y squared. So there's our relation, and we have a table of values down below. So for each one, what we're going to do is we're just going to plug in the appropriate x or y value and solve for the other variable. If I look at this first one, really, in this case, we're looking for a y-intercept. So a y-intercept is going to be where the graph crosses the y-axis. And that would happen if x is 0, because our equation can't go left or right. In this case, when x is 0, if I use x is equal to y squared, I have 0 is equal to y squared. Now I'm going to go ahead and try to solve for y. So I can take the square root, but remember, when I take the square root of something squared, I get an absolute value. And what that means is if I want to just take the square root of something, I need to do plus or minus. Now in this case, it's not going to matter because plus or minus the square root of 0 is still 0. But we need to remember that plus and minus for our answers. So in this case, our y value is going to be just 0. Okay, now let's look at our second one. In this case, our y is 3. I'm going to use the same equation, but in this case, I'm going to plug in y is equal to 3 and solve for x. So I have x is equal to 3 squared. In this case, square root, and my x will be 9. So when x is 9, my y value is 3. Okay. This next one, I'm going to plug in 25 for x and see what my y has to be. Again, I'm just going to use that relation. So x is equal to y squared. I have 25, though, in this case, is equal to y squared. And I'm going to go ahead and take the plus or minus square root. All right. So the square root of y squared is the absolute value, but I can just make it y if I take plus or minus square root. And this is going to be plus or minus 5. So I'm going to actually get 2 values out of this answer. It says you only need to identify one. So for the software, you could plug in either one, but in reality, you would get 2 values there. This is going to be, when I plug in 64 for x, I get 64 is equal to y squared, and y is equal to plus or minus the square root of that 64. And 64 is a perfect square, so in this case, y is equal to plus or minus 8. So there's only one left now. Let's see here. If I plug in -2 for y, what will my x be? Do this one up here. I'll have x is equal to, now square that whole -2, when I plug that -2 in for y, I will get x is equal to -2 times -2, that's 4. So these pairs here, but actually I have 2 for each one of these values here. We could actually plot those points, and we would find out that this is sort of an equation that looks like this and this. It's going to look like what we call a parabola. And we're going to be studying those really, really quickly. But we wanted to get you some practice with finding those values first. So this one was missed quite a bit. So I wanted to go through something like that with you. Okay. Let's see. I'm going to open up another section here. Here. So the next problem was in section 3.3. You're actually doing a really nice job on these. There are just a few that you're having some problems with. Okay. Let me see if I can find something similar. Okay, yes. So something like this where we have a complex fraction. So we want to find the slope of the line determined by the following equation and simplify our answer. We have x plus y over -6 plus 12 is equal to 17. So remember, to find the slope, I want to solve this equation for y. So if I can get that equation into the y is equal to mx plus b form, my m, whatever is in front of the x is going to be my slope, and my b is going to be the y-coordinate of the y-intercept. So I will have another point on my line, 0, comma b. Okay, the way to turn this equation into is to get rid of that fraction. So what I'm going to do is I'm going to go ahead and multiply both sides of the equation by that -6. If I multiply by that -6 on both sides, then I can get rid of that fraction. So I'm going to multiply that through. When I distribute through, I get -6 times that -6. So everything cancels out here in the denominator. I just get x plus y. -6 times 12. That's going to be a -72. And then on the right-hand side, I have -6 times 17. Right, I have to be careful here. 7 times 6 is 42, carry the 4, 6 plus 4. Okay, so -102. All right, I have my fractions cleared, so now I just want to solve for y. I'll have x plus y is equal to, if I add 72 to both sides, I would have a -30. And then I would have y is equal to -x minus 30. So what this tells me, this is in that slope-intercept form. What this tells me is that number in front of the x, -1, is my slope. And my intercept, the place where the line is going to cross the y-axis, is 0, -30. So if I'm looking for my slope, I should be able to say my slope is -1. Okay, and that one's right. Okay, another one that you were having some problems with was very similar to this. So let me see if I can pull that up. Oops, it wasn't this one. Okay, so it was something like this, where we wanted to find the equation of the line in standard form that passes through 2 points. This one might be to take a look at. The one that I had pulled up isn't totally the same, but this one actually might be a good one to give a look at. So we want to find the equation of a line in standard form that passes through the following points and simplify our answer. So there are really two equations of lines we can work with. So one is going to be the one that we just saw, y is equal to mx plus b. That one you should have committed to memory. That one works really well when we can find a slope, or we have a slope, and then we have a y-intercept, 0, something. In this case, we don't, unfortunately. So another good equation to work with is called the point slope form. And that would be y minus a certain y given point. So y minus y1 is equal to the slope times the quantity x minus a certain x1. Now this point slope formula works really well when you're given a point, which we are here. We're actually given 2 points, and we can find a slope really easily. And here we can. So I can use that point slope formula to find the equation of the line. The first thing I need to do, though, is to just choose a point. So I'm going to choose the first one. You can really choose either one. So I'm going to call this x1, y1. And then I need to find a slope. So it's really the tilt of line. It could be going down from left to right, or up, or just straight, or it could actually be vertical. So the way to find a slope is we want to look at the rise as we go from left to right. So how far it goes up over the run, which is how far it goes over. So we can say it's going to be the change in y. So y2 minus y1 over the change in x, x2 minus x1. So that's the rise over the run. All right, so in this case, if we just say, all right, this is my second point, x2 and y2, then I'm going to have 10 minus negative 10. It's my slope. Over, now I can label either point x1, y1, x2, y2, but I have to be consistent. So in this case, I've done y2 minus y1, and I do x2 minus x1. Notice what happens here, though. So I saw this one right off the bat. I was like, this is a special case. I have 20 over 0. So negative 3 minus a negative 3, that's 0. And when I have a 0 in the denominator, unless the numerator is 0 as well, that's going to be an undefined slope. So my slope in this case is a special case. It's one of those two special cases. It's undefined. What that means is, since I'm thinking of rise or run, it's going to rise 20, and it's not going to run at all. So this slope is going to be infinite. It's just going to be a vertical line. So the line is going to look like this. It's going to be vertical. And how do we figure out where it crosses the axis? We can use either one of these points. So if you look at those 2 points, it says no matter what y is, x has to be negative 3. So if I go over here to negative 3, where x is equal to negative 3, my y can be anything. See, the first point is negative 10, way down here. And the second one is way up here. But this could be anything for y. So as long as x is equal to negative 3, y can be anything. So in this case, we have what we call a vertical line. If our is undefined, it's always x is equal to something without a y. So in this case, I have x is equal to negative 3. And notice I can't use my slope-intercept form because I can't plug in an undefined point. So this is a special case. In fact, this is the only case we can't use one of these formulas. So we have to be sort of careful about this. But when you have an undefined slope, it's going to be a vertical line, and it will always be x is equal to x, that x coordinate. So when I submit my answer, that's right. Okay. We're going to look at another one of these because that wasn't the one I was looking at that you were having problems with. All right, let me clear what we're doing here. Okay. Okay, something like this would be what I was looking for. So in this case, we will use, notice that we have 2 points. It looks just like the one that we just did. So I'm going to be using this point slope formula. The y minus y1 is equal to m times x minus x1. I'm going to choose one of these points to be x1, y1. I'm just going to choose the first point. And now I'm going to go ahead and calculate my slope. So in this case, my slope, that should be y1, my slope is not going to be infinite. So I'll actually be able to calculate it. I'll have m is equal to y2 minus y1, the change in y, so the rise, over the change in x. And just be consistent here. Okay, when I plug in y2, I have 4 minus y1, which is a negative 4. That's going to be 8. And x2, be consistent, so I use my second x minus my x1, which is 4. And that would give me my slope is 8 over 4, or 2. Okay, now I can plug in my 2 for my slope. I can plug in my one of my points here. I'll just plug in this one. So over my formula here, I'm going to have y minus negative 4 is equal to my slope times x minus 4. I'm just going to do these in a different color to show you. So my y1 is a negative 4. I get that from right here. And my slope is a 2. We just calculated that. And my x is going to be a 4. Okay. So notice that it says it wants this equation in standard form. So it wants it in y is equal to mx plus b form. I'm going to go ahead and try to solve for y. So I have y plus 4 is equal to 2x minus 8. And now if I subtract that 4 over, I have y is equal to 2x minus 12. That should be my equation of the line in standard form. So notice in these cases, the point slope form works really well. All right. Oh, okay, it's an incorrect format. So standard form, mine is in slope-intercept form, right? So this form, actually, the slope-intercept form, it makes a lot more sense to put it in that way. But standard form will tell you if it's a linear equation or not. So the standard form, which isn't used too much, but it shows you if it's a line or not, will look like this. So it's going to be ax plus by is equal to c. So let me revise that a little bit. I'm glad that I actually typed that in. If I want to write it in this form, I could take this 2x and bring it back over. So I should be able to write this as negative 2x plus 1y is equal to negative 12. And that would be this standard form. So again, standard form is not the best form to interpret with, but it will tell you that it's a line. So let's see if this works. Negative 2x plus y equals negative 12. If you can write an equation in that form where both x and y, or sorry, both a and b are not 0, then it's always going to be a linear equation, so a straight line. Let's try that. All right. Okay. That was the last one from this section. All right. Let me go and check another one. There was 1 and 3, 4 that was giving those people that were working on it up to the moment some problems. So let's see here. Let me see if I can find one like it. I have it written down, but okay. I think it's something like this. So again, it's with those pesky fractions, right? We want to consider the following equation. It will be a linear equation. We want to write it in slope-intercept form and simplify our answer. So again, the best thing we can do here is just go ahead and multiply by that 2. Get rid of fractions. So if I multiply both sides by 2, that will allow me to, down the road, solve for, this for y. And that's really what I want to do, because I want to put this in slope-intercept form. So this is really the form that we're looking for. So if I multiply things by 2, I have 6. And this is where you have to really sort of be careful. I have a minus, and notice the 2's are going to cancel out here, but I'm still going to have 4y plus 7x left. And notice that this is in parentheses. That minus is going to go through, it's going to distribute again. So that minus isn't just in front of the 4y. The minus isn't just in front of the 7x. It's in front of both. And I think that that's where, if you made a mistake on this part, that it probably happened. Okay. Now I want to go ahead and distribute that minus through. So I need to distribute again. I'll have 6 minus 4y minus 7x is equal to 8. I'll have negative 4y minus x to 2. I want to solve for y, so I can add that 7x over. I'll have negative 4y is equal to 7x plus 2. And finally, I divide by a negative 4, so we're just careful here. And I will get y is equal to, I'm going to just divide this into 2 parts, so it's going to be in standard form. So a negative 7/4 x plus 2 over negative 4, and 2 over negative 4 reduces to a 1 over 2, negative 1 over 2. So I believe that looks right. Let's put it in and check it out. So that should be in slope-intercept form. So that's going to tell me that the slope is 7/4, and the y-intercept is 0, comma, negative 1/2. All right, that's right, that's good. So we can actually start plotting these things now. If I'm looking at the equation like this, I'm going to go ahead and I think I can put a whiteboard up there. I'm just going to make a note to myself here. Okay, so I want to share a screen, but I want to try to share my whiteboard here. Okay, so, okay, share screen, whiteboard, here we go. And I think, I'm not positive, but I thought I could make this. Okay, there we go. Nope, that's not really what I want. Okay. I can go ahead and make some axes here. And if I wanted to go ahead and plot this line. So the line was y is equal to -7/4 x minus 1/2. I can go ahead and find that y-intercept first. So the y-intercept is when I plug in 0 for x, it'll always be the second component. It's -1/2. So if I say, all right, here's -1, here's -2, here's -3, this would be about 0 and -1/2. Okay, I just need 2 points to plot a line. So what I can do now is I can either use that slope or I can find another point. Now it's tempting to use the slope, although in this case we have to go down 7 and over 4. So if I wanted to, I could go down 7 and over 4 to find another point if I'm careful. So I can use that rise over run. Let's see, so I have 1, 2, 3, 4, 5, 6, 7, 8. So if I went down 7 and over 4, 1, 2, 3, 4, that should give me a new point. And that point should be like right around here. So going down 7 would be like going down 14/2. And 14/2 and 1/2 is 15/2. That's 7.5. And then over 4, so I'd have 4, comma, -15/2. And now I'm going to get this in a linear form here so I can actually connect those 2 dots nicely. Maybe. Okay, so it'll look something like that. There we go. So that would be my equation of a line. Now, the next one is going to be something like, we want to find a line that's parallel to that line that goes to a certain point, or we want to find a line that's perpendicular to that line and goes through a certain point. So I'm not really sure what the problem's going to give me, but let me just show you like an example here. So let's say that they're like, well, okay, we want you to find a line that's perpendicular to that, but goes to the point, whoops, goes to the point 0, -3. But it's perpendicular to this given green line. Perpendicular. So if I have a perpendicular line, what that means is my slope is going to be the negative reciprocal of my original slope. My original slope was -7/4. We used it to find that second line. So my perpendicular slope, sometimes they say perpendicular like this slope, I'm going to flip it. I'm going to take the reciprocal, so that's -4/7, but I'm also going to negate it. So it's going to be +4/7. This is going to be my new slope. So now notice what I have. I have this new slope, but I also have a point that it goes through. In this case, it's a special point. So if I wanted to finish up this problem, I would just say, all right, I have the special point, the y-intercept. So this is going to be that perpendicular. This is going to be a new line here. And it's going to have slope of 4/7, and it's going to have that y-intercept of 0, -3. So if I just plugged it into y is equal to mx plus b, my new slope is going to be 4/7, and my 0, -3 is going to be my special y-intercept. Look like this. If I can get another line going on here. Okay, it's going to go through that point. Yeah. So that looks pretty good. So it's going to look like that. I just wanted to sort of show you what it might look like. And we say, all right, it's going to be perpendicular there. So not perfect, but that's how we're going to do something if we wanted to find a perpendicular line. We can also look at a parallel one. Now let's go ahead and see what they had in mind. So I'm going to go ahead and clear this out and go back to our problem. So that would be, let's see, sharing my screen somehow. New share, there we go, new share, screen. So let's see what they want us to do. So now they give us the same equation of the line, and we want to find something that's parallel to that given line. All right, so I did go ahead and was smart enough to write down the equation of this. So let's see. Okay, I think I'm good to go. So this equation was y is equal to negative fourths x minus 1/2. I wanted to go through this point now. This time I want it to be parallel. So what's true about parallel lines? Parallel lines have the same slope. So in this case, if our slope is negative 7/4, our parallel slope, and sometimes we use two parallel to denote that, or I do at least, is going to be negative 7/4. It's the same slope. Notice I don't have that special y-intercept at this point, so I'm going to have to use, or I can use that slope-intercept form, or I should say point slope form. So a y minus y1 is equal to m times x minus x1. All right, so let's go ahead and plug this in. So I'll have y minus 13 is equal to that slope times x minus 11. And I'm going to go ahead and solve for y. So we'll have y minus 13 minus 7/4 x. Distributing through, I have plus 77 over 4. And I add that 13 over. So I have y is equal to negative 7/4 x plus 77 over 4. And then when I add that 13 over, I'm going to make that over 4. So 13 over 4, well, 13 times 4 is 52. So now when I add these together, I would get y is equal to negative 7/4. And then I'd have 77 plus 52. Wow, that's a 9 and a 12. 129 over 4. 129 over 4, I think. I guess, well, the moment of truth will be soon. So my new line should have the same slope. So when we look at this graphically, if we remember that last line, it was coming in like this. It had a pretty negative slope, and it was going through that point below. So it was coming in like this. This line is going through 11, 13, so it might be up here, but it should have the same slope. These should never intersect. So if I go for the moment of truth, oh, my answer seems to be incomplete. All right, yeah, I didn't really submit anything. I just need to turn it back into being able to type it in. So let's try. So y is equal to negative 7/4 x plus 129 over 4. Yay, that's great. So it works out. That was one that you were having problems with. Sometimes I know that it's difficult to find that y-intercept. I mean, you can use a calculator along with things. You didn't have to add those in your head and multiply the numbers in your head. You can use a calculator to figure that out, but we do want you to be able to work with fractions. Okay. All right, so those two really good examples actually that you were having a little bit of problems with. All right, I think you're doing really well. There's one person that actually made it to 3.5 and they did not attempt or had a problem with this one. So I'm gonna have us look at one more. Okay, let me see here. Okay, so let's go back to 3.5. So in 3.5, we're doing something a little bit different, but it's in the same vein. So we're given equations, we're given linear equations, 2 or more actually, and we're trying to figure out, in this case, inequalities. So in this case, it's going to be a region. Let's just show one here. So we're just going to plot the line, and then we're going to shade a certain way. And that shading is the problem that a lot of students have. But this one that the person was having a difficulty with or skipped, it's really sort of a difficult one because it's using absolute values too. In fact, I mean, this would be a good one to do. Let's just start out with something like this, okay? So in this case, it says, consider the following absolute value inequality. Rewrite the given as 2 linear equalities. Okay, when we have absolute values, just like we saw back in chapter 2, pretty much the first thing we did, that this inequality, if that quantity is positive in there, then we want to get rid of those absolute values. So if it's, those absolute values aren't going to change it at all. So we'll have 9x plus 7 is less than 10. However, if what's in there is negative, so if that number 9x plus 7 is negative, then those absolute values are going to make it the opposite. So that'll be negative, the quantity 9x plus 7 is less than 10. So now there's a connector. So which connector is a less than connector? So when this absolute value is less than 10. If you watched any of the videos for my absolute value examples here, I'm just going to undo that because it's sort of hard to see. If it's less than, what this means is distance. So in my videos, I was saying that, you know, this absolute value talks about distance. It's really saying the distance between 9 times the number x, and then if I do minus -7 to make a plus 7, so the distance between -7 and 9 times a certain number is less than 10. So it's 10 in each direction. We're going to take this inside interval. However, if this was the other way, then we would be taking over here and over here. So typically when we have the absolute value is less than, we're going to be taking what's inside, what they have in common. We call that an and inequality. And if this was greater than, we're going to be taking those ends, and that would be an or inequality. So in this case, it's going to be an and. So let's go ahead and select that. And it says is in terms of 2 inequalities. So I should be able to say, all right, 9x plus 7 is less than 10. And I know a lot of you do this anyway, but I could go ahead and divide by that -1 and simplify this out a bit. I don't know if it'll like me putting in exactly how it is there. So I'm going to divide by -1, but when I do that, I need to switch the inequality. So I'll sort of write it up there in just a minute what I'm doing here. So and 9x plus 7 is greater than -10. So what I've really done, let's make sure that's correct first. Okay, good. So what I've really done here is distributed or divided by this negative sign. So when I divide by the -1 on both sides, this sign needs to be flipped. So I have 9x plus 7. I flip the sign and I make that, and that's where I got this part here. Okay, so let's look at the next bit. Oh. All right, I'm going to write those down because I'm not so sure that it's going to transfer my work over to the next one. And you should always be writing these down, by the way. I need to set a good example here. One other thing you might want to just sort of look at here before I go on to the next one. Sorry that I'm extending this a little bit, but we saw maybe in my notes or the videos I did, if we had a less than in absolute values, notice if we put these two together, we have this common 9x plus 7. We have that it's less than 10, but it's also greater than -10. So only when you're using this less than, you can actually write it as -10 or negative whatever that number is less than the thing in absolute values is less than 10. And sometimes that makes it easier because these are, this is called a compound inequality, but it only works with that less than. All right, I just wanted to show you that, just in case you forgot about that. Okay, so now it says, okay, so which graph is represented by the original inequality? Okay, so I have 4 to choose from. All right, so I'm gonna go ahead and clear this out a little bit. So I had 2 inequalities, and notice that these are graphed on the XY. So back in chapter 2, we were just looking on the x-axis. Now we're looking at 2 dimensions. So we're looking at actual lines dividing these things. And this should sort of make sense because the 2 inequalities were 9x plus 7 is less than 10. And the other one was 9x plus 7 is greater than -10. If I was to put this in a standard form, well, not a standard form, but the y is equal to mx plus b form, the slope-intercept form, couldn't do it because there's no y, right? But we've seen these before. These are going to be those vertical lines, and you can see that those are our choices. So if I solve these for x, I have 9x is less than, subtract 7, so that's 10 minus 7 or 3, and x is less than 1/3, so 3/9. Over here, if I subtract 7, I have 9x is greater than -17, so I have x is greater than -17/9. And I have to have these both happening at the same time. So where is x greater than, or sorry, less than 1/3? Okay, so these two here look like an x is greater than, or sorry, less than 1/3, or an x is equal to 1/3, I should say. So we're going to narrow it down to those two. All right, maybe I'm going to try to move this screen up a little bit since I've narrowed it down to these two, because I have that these are x is less than 1/3. Now I have x is greater than something negative. -17/9, that's almost -2. So actually these are both at that point. Notice that since these don't have equals, these lines are both dashed. So we don't include those points. So now the connector becomes important. And the connector that we had here was an AND connector. So we have to have everything where x is less than 1/3, so it's going this way, and everything x is greater than -17/9. So that's this way. So the AND connection is like an intersection. It's like this gate, that intersection gate, and it means take what it has in common. So On the number line, it would be this part, and it wouldn't be the whole thing. So this one over here would be an OR connector. Well, it wouldn't actually be an OR connector. OR connector would actually give you everything, but an AND connector would only be what's in common. So we're actually going to be taking this graph here. Okay, all right, that's right. Okay, so now let's get to the problem that you were actually having problems with. Okay, let's see if we can find it. Oop. Oh yeah, I just want to keep skipping on until I find it. Oh, that was it. Oh, all right. Let me try this again. Exit. So the one that was skipped was actually pretty difficult. I was sort of saying, okay, they were like these absolute value inequalities. Okay, it was like this. So we have 8x plus 4 is less than or equal to 15, or absolute values of 8y plus 4 is less than or equal to 15. So these two, I would say, let's make them into compound inequalities to get rid of those absolute values. So if we do that, it becomes a little bit more efficient. We can say that the first one is negative 15 is less than or equal to 8x plus 4 is less than or equal to 15. So now that we have equal to, those lines should be solid. And notice that all these are solid. Or, so an or is a union. So that means we're going to be taking everything. And this one is going to be negative 15 is less than or equal to 8y plus is less than or equal to 15. Okay, so I have two double inequalities there. So in the left one, over here, I'm going to subtract 4 everywhere and solve for x. And I have negative 19 is less than or equal to 8x is less than or equal to 11. And if I divide by 8, I have negative 19/8. So again, that's a little bit less than negative 2 is less than or equal to x is less than or equal to 11/8. And that's a little bit more than 1. So this is on the x-axis. This means that these are vertical lines. So we're looking at all the x values that are in between these 2 points. So let's see if we can find that, if we can eliminate some graphs here. All right. So the things we can eliminate are going to be, okay, definitely we can eliminate this one here because it has only one line, one vertical line. So that one can be eliminated. The other ones are all fair game. Oh, well, not really. This one has a dashed line, right? So that one can be eliminated too. So really we're looking at, oh, there's more, sorry. Oh, there's lots more. Okay. So we can't really eliminate a lot, but we do have these 2 lines. We can eliminate this one too because there's a dash there. Okay. So now let's go ahead and get that second one here. Let's see. Okay. These over here are going to be y lines. So what I mean there is my slope is going to be 0. So they're going to be horizontal lines. Again, I'm going to subtract 4. I'm going to have negative 19/8. So this is going to be the same thing actually, but it's going to be on the y-axis. And then I subtract 4 over here. So that 15 minus 4 is 11. And I'm dividing by 8. I think I did that in 2 steps, but this is going to be the same exact thing as we have on the left-hand side. So now I know that I have that little x area, they're both solid lines. I'm going to have that little y area. So if I was writing this as an equation, y is equal to 11/8, 0, 11/8 would be my y-intercept. My slope is 0, so these are going to be horizontal lines. So I'm looking at these two, and we want to have a union. So we want to take what's in common with everything there. It's going to look a lot like this graph here, but it's going to have solid lines. So let's see if we can find that one. It looks like this one right here, right? Okay, so in fact, the only ones it looks like are, to me at least, are these two here. So it could be this one here, or it could be this one here. So which one is it? Let's see. They look identical. But maybe not quite. Not quite. So this one has, notice that this one here, I'll show you the difference. This one only has this area, and that would sort of mean an intersection. So it's not going to be that one. It's going to be this one where everything here and everything here is, so this one's going to be the union. We're going to be using that graph. All right, my drawing is very cluttered now, so let me see if I can just undo some of that. Okay, so it's going to be this graph here. And that one was more difficult. All right. Okay. Well, I hope this has helped. Didn't have anybody in office hours tonight, but I hope that this little lesson will give you a chance to go through. And if you go through these, that's great. And you might be saying, "Oh, I know how to do that." So just fast forward through that part and get to something where you might be having problems. And remember, you can always ask me questions on these things. All right. Have a great night.